Hi.
Good morning again.
Good morning, Raphaël.
So now we are supposed to talk about space and infinity, the infinity of space. I don't know how we could take it. My first question, because I had this thing, I don't know why I didn't think about it before, this night, as I told you, about Plato, because with Plato, like mathematics is actually related, is de facto immediately related to space. And for him, when we talk about geometry, that's actually a synonym of mathematics, it appears in Plato, when it's written like that no one enters here if he's not a geometer or mathematicians. That's basically meaning the same thing. Do you have something to say about that? Does it ring something? Do you agree, actually?
No, actually, Greek mathematics is based on geometry, partly because with the discovery of irrational numbers, numbers that are not a ratio of two whole numbers, geometry looks more real. It looks like a more solid, perhaps they thought, a more solid foundation for mathematics than.
What do you take? What you mentioned?
Numbers.
Irrational numbers. What did you mention that?
Well, there's the discovery that the square root of 2, the diagonal of a unit square, you have a square, one unit on each side, and the diagonal is the square root of 2, is its length, and they discovered that this could not be expressed as a ratio of two whole numbers, this length, the square root of 2. And I think that led to the idea, I'm not an expert on this subject, but that
doesn't matter.
Geometry was a more solid foundation for mathematics than just numbers.
You think I'm not an expert either. We are here just to talk very casually together, but do you think that's Greek that invented the irrational number, or I don't know?
They discovered
that?
Irrational numbers. Yes.
They did discover irrational numbers, wasn't?
The proof is attributed to Pythagoras that the square root of 2 cannot be expressed as a ratio of two whole numbers.
But they didn't call them irrational numbers, I guess.
You would like to know exactly what the ancient Greek
was. It's a bit my
was.
obsession,
Yes.
because
no, I don't know ancient Greek. I don't know what it was in ancient Greek. But certainly they expressed themselves geometrically, and I remember my friend Benoit Mandelbrot was writing his memoirs.
Yeah, we'll come back to him afterwards.
He wanted to say memoire d'un géomètre. He wanted to have that.
Yeah, for him, he feels like he's like a Greek, because he interprets the fact that he's a mathematician, but in fact he's a geometer.
Yes, and I'm sure the title would have come out like that if he had been alive, but unfortunately he passed away before the book was published. And the publisher changed it to a very pedestrian title. What was it? Something like Memoir of, I don't know, some kind of rebel or unconventional person or something like that. And Benoit wanted a more classical.
Yeah, of course. The publishers and journalists, they always love everybody to be some kind of a rebel because it sells more.
So they ruined the classical title that Benoit had chosen.
Because I was wondering if the
scientific maverick. Memoir of a scientific maverick is what.
All right, scientific maverick is even worse. It's really even worse.
Geometry has a classical ring.
That will have been better. I'm sure that will have been better. So, do you think it's some kind of logical or natural that mathematics will, to think mathematically was to think first about space. The fact that it's the very idea, not only space like empirical space, but the fact that you think about space, it makes you think about measures and things that are directly related to mathematics.
Geometrical intuition, the eyes, the visual system is tremendously powerful in human beings. Numbers are already more abstract. but then Bourbaki comes and prohibits diagrams. You get shot if you want to include a diagram in a math book, you know. And I think that's like handicapping somebody, chopping off your arms or your legs.
Because coming back to the, you know how I love etymology and things like that, theoria, that means to see. So a theorem, I suspect, I don't know specifically, might be a way to see.
Right. So it's a shame not to use the visual system of the human being. Until relatively recently, geometry was really the foundation for mathematics, and this arithmetization movement was it the late 1800s, the arithmetization of analysis. And then with Bourbaki and van der Waerden, everything went in a algebraic direction, which I don't have any intuition at all, but most of mathematics now is heavily algebraic. Algorithmic information theory isn't. But anyway, space is a interesting subject because maybe it doesn't exist. You know, the latest experiments in quantum mechanics, Anton Zeiliger was mentioning, the physicist in Vienna, was mentioning that with entanglement there seems to be some connection which is instantaneous and at a distance, and they've been doing the experiments with greater and greater distances. And so he was commenting that space doesn't seem that real anymore, and apparently you can do something similar with time.
That's interesting because for the Greek, for Plato at least, the only thing that is, if I could allow myself to say that, really real is space. And he completely disregarded time. And for him, time is the pure illusion, and also what is what destroys everything, what makes you, what blurs your view. So what blurs theory, what blurs the view of real thing, that blurs even not only outside but inside yourself, that blurs the very fact that you already know what is the real, but you forgot about it because time, because the change of things. That's the reason why the definition of time in Plato is the mobile, can you say mobile in English? Mobile, the mobile image of...
the moving image.
The moving image of eternal, unmoving, unmovability, or I don't know.
Yes, he doesn't like time. He likes to think that everything is eternal. Yeah. The real truth.
Time is static and eternal. It's just destruction. It's just forget. The fact that you forget. That's the reason why the main objective of dialectic is to is what he call anamnesis, is to find what you already know but you actually forgot, and the very thing that you actually forgot is actually mathematics. Because mathematics, it's what it means etymologically. Mathematics, that means mathema, something that is already here. That is, it means a priori, knowledge, a priori knowledge. That means, but completely a priori knowledge, like meaning in a way, it's already here, but you forgot about it. That's the reason why, even when in the Republic, when he say, you don't teach mathematics the same way you teach other things, because you're not here to add something to the student, to his, that he doesn't know. You just need to help him to get rid of everything that he thinks he knows but is actually just fake. And the very reality of the theorems, like the view, the mathematical view, will come up all by itself. It's the way to teach mathematics. Do you agree with that?
Well, it's nice to have someone who loves mathematics so much as Plato does, you know.
But do you agree that to teach mathematics, you don't have to add something like technically to the people, but you just help them to get rid of everything,
well,
so it will come.
Menno the slave has to remember, right? The French educational system used to emphasize mathematics quite a bit, did it not?
Yeah, it quite a bit. It's just like the obsession. That's the main. Yeah. That's the only. The people that are not good in mathematics, and That was my case. They are regarded like in a very, with contempt.
Yeah, I've heard jokes about French engineers from the École Polytechnique. They're wonderful at mathematics, but maybe they're a little too theoretical.
No, they are very theoretical. Yes,
Yeah.
they are completely theoretical.
Mm-hmm.
Yeah, but do you
So space is very problematical. Another question is space continuous or is it discrete? Is it
That's a
infinitely
real
divisible?
Yeah, and
Yeah.
so we are going to talk about that maybe a little bit later when we are going to talk about Mandelbrot that you already. But just to emphasize a little bit more on this question of space before we think about discrete, undiscrete, that will right away let us dive into the question of infinity. The idea that there is a mathematic that only deals with space, and basically it's what we call theorems. The theorems, when Pythagoras, he was doing mathematics just with the view, just with space. And do you think there is a change? I mean, a real
Or you can use
transition?
pebbles. You can
Yeah.
use pebbles.
Yeah.
That gives you an idea of whole numbers
Yeah.
on the sand, for example.
Yeah, because do you think there is some kind of a transition, I would say, with Descartes when he invented, as far as I know, what is called analytical geometry? Do you think there is a change not only of method, but a change of mind, of paradigm, of the way to deal with? Because he didn't deal anymore with when he will talk about a triangle, he will not anymore be about a property like the Pythagorean property of the triangle or things like that, but it will be about a triangle. It will be 2x plus 2y equals things like that.
Yes. Well, that's Descartes starts the algebraization of geometry.
Yeah, what we call in French analytical geometry, but I don't know how.
In English also it's called analytic geometry. Yeah, but his I think as a philosopher he also felt that like Plato, he felt that mathematics was very fundamental to Descartes. By the way, it used to be Descartes if you look at the old manuscript.
Yeah.
Pascal also. Descartes is taken as an atheist, I believe, but Pascal, who is very much a believer,
think Pascal, he wasn't into
was
space
also
anymore?
a mathematician.
Yeah, but he wasn't into space anymore. I think, I don't know, I'm not a specialist of the part of the mathematical part of Pascal, but he was more about calculations, like the father of La Pascaline, the first machine to...
Right, the first calculating machine.
Calculating machines.
Right, and then Leibniz also did a calculating machine. He was trying to have one that would multiply, I believe.
Yeah.